All right, so let's start. Thanks everybody for the attendance. I'm Joao Sanchez, Ph.D. candidate of the agronomy, and I'm going to follow up with my presentation entitled Evaluation of Management Practices to Improve Pintoi Peanut Productivity and Nutritive Value in South Florida. This presentation is part of my Ph.D. thesis, which was defended on last Tuesday, and my committee chair is Dr. Joao Vendramini here from the Research Center, and my committee co-chair is Dr. Lynn Sullenberger from the Agronomy Department in Gainesville. So, my presentation will be divided in 3 sections. In the first one, in the introduction, I'm going to talk about the Pintoi peanut, what it is, what is its importance, and why we wanted to know about it, and also about my general objectives. Then I'm going to switch to the second section, which is my research projects, 3 of them, and I'm going to describe in the last section is the conclusions. So beginning with my introduction, I would like to start saying that, as you all know, nitrogen fertilization is a critical issue here in the state of Florida, and we usually have very limited nitrogen application in our grasslands, especially those areas that are devoted for beef cattle production, and mostly due to the economic constraints to the short profit margins of the activity. One of the alternatives proposed by researchers is the use of warm season legumes in mixture with our tropical grasses so they can provide the whole grasslands with nitrogen from the atmosphere. However, one of the main problems with this practice is that we currently have very few legume species that can persist in mixture with those grasses, and we are looking for new ones, and also trying to improve the management strategies for the ones that we already know they are persistent. So the perennial peanuts are some species designated as perennial peanuts. They have been known around the world in subtropical and tropical areas for being really persistent when in mixture with tropical grasses. And one species in particular has gained a lot of importance, especially in South America, and it's Pintoi peanut, which I'm going to talk about in detail now. So Pintoi peanut, also known as Arachis pintoi, is a species from the Calorhizae section of the Arachis genus. Also, it is a perennial plant, and like all of the other peanuts, it is native from South America. And this one particularly is native from the valleys of the Jequitinhonha and São Francisco rivers in south of Bahia state and north of Minas Gerais in Brazil. This plant is adapted to a wide range of rain precipitations ranging from 60 to 140 inches, and also tolerates acidic, low fertility soils, particularly soils with high aluminum saturation. And also, as observed by some researchers from the University of Florida, it can tolerate severe frosts, so it tolerates the winters in Florida really well. It comes back in the spring. This is a general overview of the morphology of the appearance of Pintoi peanut. So its main growth habit is by stolons. So it's a stoloniferous plants that grows mostly laterally, sending those stolons that colonize new areas in the canopy. And whenever they touch the ground, they may produce adventitious roots, secondary roots that help this plant to better establish in the area. Additionally, unlike other species of perennial peanuts, this one produces viable seeds, so it can produce those pods that you see in the picture that can be used to establish new areas with this plant. Regarding its herbage accumulation, we have variable data from different parts of the world. And in places where Pintoi is not very well adapted, the productivity can be as low as 0.3 tons per acre. But in places like in South America, where it's really well adapted, it can produce as much as 5.8 tons per acre, which is almost the same as what we have for the rhizoma peanut here in Florida. The nutritive value is really similar to other warm season legumes. So what we have in terms of crude protein is a range from 13 to 18%, and then for the in vitro digestible organic matter concentration, we have an average of 65%, and sometimes it can be greater than 70% of digestibility, organic matter digestibility. Regarding its establishment, as I said, one of the main advantages of this plant is that it can be propagated by seeds. So especially when we compare it with the Rhizoma peanut, which is a perennial peanut species that is really well known here in Florida, the Rhizoma peanut cannot be established by seeds. It does not produce at least enough seeds to make it worth to harvest them. So it is established by the rhizomes, but Pintoi can be established by seeds, which represents an advantage for this plant. Unfortunately, given the seed production levels that we have currently, seed prices are usually expensive and the availability is limited. Also, another important characteristic of this plant is that it has a slow establishment that has to be considered when it is to be established in a common area by a producer. So it has a slow establishment. One of the strategies that we can use to improve the establishment rate is the use of nitrogen. So we have some data from South America saying that nitrogen fertilizations up to 50 pounds to the acre during the establishment can increase the above ground portion of the peanut and increase the speed that it covers and colonizes the soil surface. However, those experiments that were done in greenhouse and also in small plots, and we do not have data to prove if the same advantage of using nitrogen would be achieved when Pintoi was used here in Florida in our kind of soil and in mixture with our kind of grasses. So it's still a question that we need to answer. Regarding the establishment of Pintoi in mixture with grasses, we know that we do not have a lot of literature covering this subject. Most of what we have regards the establishment of Pintoi with some type of brachiaria, usually palisade grass, and also most of what we have regarding the establishment of Pintoi peanut from vegetative material, from the stolons. So we have very few seed literature. For example, a question that we raised was, is it possible to establish Pintoi and a companion grass by seeding both together? However, I did not find an answer for this question in literature at least, so we still need more research on this subject. Regarding its harvest and grazing management, given its low profile, its low growth habit, Pintoi peanut tolerates short stubble heights as low as 2 inches. And also, when it is in mixture with other tropical grasses, Pintoi peanut really benefits from more intense grazings or harvests. So usually what we have is, as we decrease stubble height, we increase the proportion of Pintoi in the canopy because it can protect itself from grazing and harvesting. One of the interesting characteristics that has gained a lot of importance in the last years is the impact of some management practices on the soil organic carbon in agricultural areas. And we know that mixing legumes into grasslands has the potential to increase soil organic carbon. And we have a case in literature for Pintoi from Mosquera and collaborators in Colombia, which indicated the potential of this species to increase soil organic carbon contents and concentration. However, the authors also found that such advantage is dependent upon some factors like soil characteristics and also climatic characteristics. Therefore, we don't really know. We don't have data if the same thing would be observed here in Florida, and this is also a question that we will need to answer. So we know that at least the beef cattle industry here in the state has the demand for a warm season legume that is really persistent in mixture with the grass. Also, there is perennial, especially that has the advantage of being established by seeds, and Pintoi peanut has all the potential to be the species. However, we have currently very few studies that were conducted with Pintoi here in Florida. Most of them were in small plots, and we need to do more research to test this plant, its performance in real productive situations, in regular production environments that we observe here in Florida. And therefore, the objective of my dissertation was to evaluate management practices to improve establishment, productivity, and nutritive value of Pintoi peanut in South Florida. And to accomplish with this objective, we conducted several experiments, which I'm going to describe 3 of them right now. So, first one is entitled Forage Characteristics of Bermuda Grass Pastures Overseeded with Pintoi Peanut and Grazed at Different Stubble Heights. The objectives here were to evaluate the persistence, productivity, and nutritive value of Bermuda grass and Pintoi mixtures as affected by different stubble heights. So our hypotheses here were that Pintoi will persist in the mixture, the short stubble heights will benefit Pintoi, it will increase its proportion in the pasture, and also that pastures that were overseeded with this legume will have greater productivity and nutritive value in comparison with pastures that were grass monoculture only. This experiment was done at the Range Cattle Research and Education Center in Bermuda grass pastures that were already established by the time that we used them. And they were overseeded with Pintoi in June of 2013. Just to mention, they were Jigs Bermuda grass pastures, as Jigs is one of the most adapted Bermuda genotypes for the poorly drained soils of South Florida. And our pastures in May of 2014, they were fertilized with phosphorus and potassium only. We did not use any nitrogen in this experiment. And the experiment lasted from June to October of 2014 and 2015. Treatments were the split plot design of 2 factors. First was sward type, and we had Bermuda grass monocultures and Bermuda grass overseeded with Pintoi and sward type. And also the other factor, which was the subplots, was the stubble heights, and we had 6 and 10 inches. So this experimental design was a randomized complete block with 4 replicates, and the grazing management that we use in those areas was a mob stocking. So for those that are not familiar with the mob stocking term, mob stocking refers to a very high and intensive defoliation and grazing for a short period of time, and then we removed all of the animals. So we had the grazing for 1 to a couple of days only, and then we had a resting period of 28 days. The animals did not stay in the area the whole time. We only used them to graze. We evaluated botanical composition, which was represented by the proportion of Pintoi in the canopy, and we evaluated it at the beginning of the experiment in 2014 and also at the end in 2015. We also evaluated herbage accumulation rate and nutritive value, which was represented by the concentration of crude protein and in vitro digestible organic matter. Beginning with our results now, we had no effect of stubble height on the proportion of Pintoi peanut in herbage mass, in an average 4.7%. So as disagreeing with our hypothesis, we did not have any stubble height effect, and we believe that the reasons for this lack of effect they were likely related to, first, the reduced Pintoi productivity here in our area. We know this not only from this experiment, but also from the others, that the plant is not really productive. So one of the reasons for this lack of difference may be this productivity, and also it might be related to the differences in our companion grass. So we know from literature that the grasses the other authors used, they're usually taller, and they are bunch grasses, and they have more bare ground spaces between them. We believe that our Bermuda grass had really little amount of bare ground, and they might have affected, it might have caused this lack of response. But one of the interesting points that we noticed was that the proportion of Pintoi peanut in the mixture increased from the beginning to the end of the experiment. So it is a very strong indicative for us that at least this plant is persistent. It really persisted in the mixture. However, one of the points that I also need to mention here is that the proportion that we observed was indeed low. We were expecting at least 20%. And such level of proportion of legume in the mixture is usually required if we want to have the benefits from biological nitrogen fixation, but the levels that we found, 4.7, are very unlikely to contribute. And it is likely to be the main cause for this table that I'm going to show right now, the results that I'm going to show here. So this table shows the effect of overseeding Pintoi on the productivity and the nutritive value. So for those that are familiar with statistics, if you see those p-values, as they are greater than 0.1, they indicate that we had no effect of overseeding Pintoi in our variables. And as I said, it is mostly caused by the low proportion of Pintoi in the mixture. So as we know it is persistent, now we really need to come up with better strategies to improve this proportion in the mixture. Now talking about the soil carbon and nitrogen pools of Bermuda grass pastures as affected by overseeding with Pintoi and grazing stubble heights. This is the title of my second project. So the objectives here were to evaluate the effects of the same factors as I previously described, so overseeding Pintoi and stubble heights on soil carbon and nitrogen pools in Bermuda grass pastures. So our hypotheses here were that overseeding Pintoi will increase the nitrogen, the soil organic carbon and nitrogen, as I mentioned in the introduction section. And also, as we were working with stubble heights, we also hypothesized that increasing stubble heights will increase soil organic carbon and nitrogen pools. And it happens usually because when you increase the stubble height, usually in literature, you will also increase primary plant productivity and also the deposition of carbon and nitrogen compounds. And you end up with a greater amount of those nutrients in the soil organic matter as well. So the experiment was pretty much done in the same area, same time, same treatment, same management, same experimental design as the previous experiment. So all that we did was just going there at the end of the grazing study and take soil samples. But just to make it clear again, the experiment was done here at the Ranch Cattle Research and Education Center. The same thing, as I said, as the previous. And the period was from June of 2014 to October of 2015. So about 2 growing seasons that we used as experimental period. Treatments, again, were the split plot design of sward type, and we had Bermuda and Bermuda overseeded with Pintoi sward type, and stubble heights. We had stubble heights of 6 and 10 inches. Experimental design was a complete block, randomized complete block with 4 replicates, and the experimental units were mob stocked, as I said. Big group of animals that grazed during a short period of time, and then they were moved out of the area. So we collected soil samples by the end of our 2 growing seasons in 2015 and separated them by depth, 0 to 2, 2 to 4, and 4 to 8 inches. And also, we fractionated our organic matter in different pools. And why we did it? We understand that for soil carbon evaluation purposes, 2 growing seasons is a really short period. And if you were to evaluate the effect of management practices in the total soil organic carbon in this short period, it is very unlikely to get any difference of treatments. However, we have ways to separate fractions of that organic matter that are mostly composed by recently deposited material. So those the recently deposited material is much more sensitive to short-term management changes as we had here in this experiment. I'm sorry. And I'm going to describe the fractionation methods now. So we first separated what we call a sort of particulate organic matter, and the separation is simply a dispersion of a soil sample and a washing of the sample over a 53 micrometer sieve. So the portion of organic matter that was retained in the sieve is considered to be the particulate organic matter, which is much more recent than the passing fraction, and the passing is considered to be the organic matter associated with mineral fraction. We subsequently subdivided our particulate organic matter, which was the retained fraction, into light and heavy fractions based on their density. So the density of the solution, we separated them with a sodium iodide solution whose density was 1.8 grams per cubic centimeter. So whatever was less dense than 1.8 was the less light fraction, and a portion of organic matter that was more dense than 1.8 was considered to be the heavy fraction. And here, for our purposes, the light fraction is more recently deposited than the heavy fraction. So the light fraction, it was our earliest organic matter that went to the soil, and this is where we mostly expected to find our differences. So we evaluated the soil organic carbon and nitrogen concentrations in all of those fractions. However, due to the time limit of this presentation, I'm going only to present the light fraction data. That is where we found our differences. So beginning with the results now, this table shows the effect of sward type on our light fraction carbon variables, response variables. And what we found, the only significant effect that we had was an increase in light fraction carbon concentration at this top layer. Sorry, I forgot to change to English units, but 0 to 5 centimeters is the same thing as 0 to 2 inches of depth. So we had an increase in light fraction carbon concentration with the presence of the legume. And it is in agreement with our hypothesis. So we expected to observe something like this. However, we also expected to obtain at least an increase on light fraction carbon content as well, the mass of carbon per acre. However, in this case, we did not get any differences, and we believe that the reasons are most likely related to the higher variability in this response variable, and also to the short term that we had. So we believe that if we had conducted the experiment for a longer period, we would likely have greater light fraction carbon content as well for Bermuda and Pintoi mixture, at least in the top layer that we evaluated. So for us, this is an indicative of a potential of Pintoi to really increase carbon in the soil. And this table brings the results of the same variables as affected by stubble height. So here, disagreeing with our hypothesis, we observed that increasing the stubble height was related with a decrease in the light fraction carbon concentrations. And here we had effects in the top layer, and on the 10 to 20 centimeters, the same as 4 to 8 inches. We had decreases in carbon in those two layers. And unlike most of the literature, when we increased our stubble heights, we indeed decreased our primary plant production. So we ended up with a greater accumulation of really old and mature tissue in our pastures, and those tissue, they produced less forage than the shorter stubble height. And it is likely to be the reasons for those lesser carbon concentrations in the light fraction as we observed here. Same thing as in the previous table. If we had conducted this experiment for a longer period, I would expect to find the same results on the light fraction content as well. But the general knowledge we got from this is that grazing Bermuda grass at 10 inches might be potentially, it has the potential to decrease soil organic carbon in the soil. Sorry. So here, the last experiment is entitled Evaluation of Seeding Strategies of Bahia grass and Pintoi peanut pastures on pasture establishment. So here, the objective of this experiment was to evaluate the establishment parameters of Pintoi peanut and Bahia grass stated as monocultures or mixtures. And here, just to give you a little bit of background about why we chose Bahia grass, it is the most planted warm season grass in the state of Florida in terms of area. And also, Bahia grass is a warm season grass that has a very slow establishment, similar to Pintoi peanut. Therefore, we thought that if we planted those two plants together in a mixture at the same time, one would not interfere with the growth and establishment of the other, at least in the early phases of the establishment, because they grow really slowly. And now this is what we hypothesized. And we also hypothesized that increasing nitrogen fertilization during this phase would increase the growth establishment rate of those plants, those two plants, sorry. Experiment was done here at the Range Cattle Research and Education Center in Ona, and the experimental period was from June to October of 2014 and 15. Just to make it clear, we studied the first year establishment only, so in each of those years, we plant a different area, right? And those areas were preparated by spraying glyphosate around 30 days before planting and rototilling them on the day 20 and on the day 1 before the planting. Treatments were the split plot design of seeding strategy, and we had seeding strategy, we had the levels of Pintoi monoculture, Bahia grass monoculture, and Pintoi peanut Bahia grass mixture, planted in mixture. We had those three treatments in this factor. And we also had the nitrogen fertilization strategy that we used 30 or 80 pounds of nitrogen to the acre. And here just a little bit of explanation. The 30 pounds of nitrogen to the acre was chosen for, it is the minimum recommendations for the establishment of Bahia grass here in Florida, which it has to be applied after the plants start to germinate. And also, given that we were using at least 30, we decided to try in some areas to put 50 pounds of nitrogen more to the acre and see what was the results on those plants. So this is why we chose those two doses that you're seeing. So experimental design was a randomized complete block with 4 replicates, and we evaluated plant density, which was the number of plants per square feet, frequency, and for those of you that are not familiar with frequency in this case means the distribution of the plants. So we had a big frame that was subdivided into 100 small squares, and we accounted how many squares in the same area in which our plant was present in. So just an example, if we accounted 20 squares where the plant was present out of 100, it means that we had 20% of frequency. We also evaluated ground cover in 2014 and 15 as well, but it was only at the end of the experiment. So beginning with the results and confirming our hypothesis, most of our variables for the two plants were not affected by mixing the plants in comparison with their monoculture. So Bahia grass frequency and ground cover was the same, regardless if the Bahia grass was a mixture with Pintoi or if it was planted as monoculture. And the Pintoi peanut density and frequency, same thing. They were the same independently if Pintoi was as a monoculture or as a mixture. we had only two effects of seeding strategy, which I'm going to describe now, and they were interactions. So the first one was an interaction on Bahia grass plants density, the number of Bahia grass plants. So we had an interaction between seeding strategy and month of evaluation, and this interaction happened because in July, the first month of evaluation, we had a greater Bahia grass plant density for the Bahia grass monoculture in comparison with Bahia grass mixed with Pintoi, indicating that the presence of Pintoi somehow decreased the population of Bahia seedlings. But in the further months, this difference disappeared. So it is, at least for us, it is an indication that it's not a major problem. Both the mixture and the monoculture of Bahia will end up with similar number of plants. And we also had a seeding strategy effect on the Pintoi peanut ground cover. And here, we also had an interaction between the seeding strategy and the nitrogen fertilization. So here, our interaction happened because when we switched from 30 to 80 pounds of nitrogen to the acre, our Pintoi peanut ground cover increased only when Pintoi was planted as monoculture. But when it was a mixture, nothing happened with this ground cover. And it might be related with the presence of Bahia grass. So we know that Bahia grass is more efficient in capturing and using the nitrogen than the Pintoi peanut. However, we also had a lot of weeds in both of those plots, and those weeds were the majority of the plants. Therefore, we still needed to better study it to really see if it was the presence of the Bahia or what factor that really caused this interaction. So switching now to the effects of nitrogen fertilization strategy, what we observed was that Bahia grass, at least for those variables that I'm showing now, nothing happened with nitrogen fertilization strategy changing from 30 to 80. And for Pintoi, we had an increase in the frequency, in the distribution of those plants through the area. So independently of Pintoi peanut being mixed or not, applying nitrogen increased its frequency. And even though we had if the increasing in nitrogen was dependent on seeding strategy for ground cover, this is a plant that tolerates shading, so it really spread to the area, and we believe therefore that applying this extra nitrogen is a strategy to improve the establishment parameter of this plant. Now, proceeding with the conclusions, we observed that Pintoi is really persistent in mixtures with Bermuda grass, even though it did not respond to stable height. And also, if the same management strategies that we used are to be used again, we believe that the proportion of the peanut will be reduced in the pasture, and therefore it's very unlikely to contribute with some extra nutritive value or productivity, at least in the early phases of the mixture. Therefore, we need to come up with better strategies to improve this proportion early in the pasture. We also observed that even though Pintoi peanut is present in a small proportion, it was enough, at least to give us an idea that it has a potential to increase soil organic carbon and nitrogen. And also we observed that the stubble heights that we use, if we are to use 10 inches stubble height, we are likely to be reducing our carbon stocks in soils in the long term. Finally, we observed that Pintoi may be simultaneously seeded with Bahia grass when we are establishing a mixture of those two plants. And by seeding them simultaneously, we are not causing major problems of the establishment of either plant. And also, using an extra 50 pounds of nitrogen is a strategy to improve the establishment, at least of Pintoi peanut, the spread through the area. And that's all that I had. So I'd like to thank my committee members for all of the help and the support they provide me, for all of the guidance on the conducting and analyzing the data. Also, I'd like to thank the CAPS Foundation of Brazil for sponsoring my program, to making it possible for me as a Brazilian student to come here to the University of Florida and finish and go through and finish my PhD program. And also I'd like to thank all of the employees, students, visiting scholars, faculty members, and all of the friends that I made here at the Range Cattle Research Centers, Range Cattle Research and Education Center. You were very, very important to me. And with that, I will open to questions. Thank you very much.